how late is the cone open? They're open through they're open pretty late now, right? Wow. Cool. And are they open into the fall pretty far? Are they open they're not open year round, right? Okay. Okay. All right. Gotta get my cone in. All right. So let's go ahead and get started so I can send you guys on your way. And if Josiah and Kyla join on, we will catch them up. So we kind of started off 1-1 on Monday, and we talked about the number line and the properties. And this section is, should be pretty easy. I hope so, because it's kind of getting us back into it oh, okay, I got to remember how to do algebra again and how these different things work. So there's number 3 and number 4 that we didn't do. No, I don't want to restart my device. We're only having good things happen. I had to restart my device thing come up. So we have 2 other problems on here that should be pretty straightforward, but good to review. And if nothing else, good to wake our brains back up. Okay. So the first one is a rate problem. So it says you travel 60 kilometers in 1.5 hours. What is your average speed? All right. So I don't know if you guys are drivers yet or not, but when you become a driver, you pay a lot of attention to the speed of the road that you have to go on. And usually in the US, it's measured in miles per hour, and everywhere else it's measured in kilometers per hour. So this book went with kilometers, I guess. So what we're looking for is a rate of speed. So we're basically looking at kilometers per hour. The thing to remember with that word per is that PER is that's basically giving you a indication that you need to use a fraction. All right, so this is as simple as we want to know how many the speed is measured in kilometers. And I apologize, I have a pen that works on my screen and I can't find it, so I'm using this pen that doesn't really work in my mouse. So it's kind of, so you want kilometers per hour. Okay, and they tell us 60 kilometers in 1.5 hours. So that's basically as simple as doing 60 kilometers in 1.5 hours. Come on, pen, you can do it. Oh, goodness. It's going to be a long class if I can't write on here. All right, so then if you do the math, which is basically 60 divided by 1.5, you're going to end up with, it's probably faster, I'll just type it. You're going to end up with 40 kilometers per hour. And it really is just that simple. Okay. The other 4A, B, and C have to do with conversions. And I know this is what my kids would tell me. I know I can just convert it on Google, which is true. However, if you have taken your sciences yet, physics, chemistry, all that, the idea of converting is all over the place. So you need to be able to convert so you can show in your notebook how you made the conversion. Okay, so we're going to do conversions using something called a unit multiplier. So again, this might be a review for you guys, but I don't think it hurts to review it. It's a good, if nothing else, it's an easy thing to do. So we're going to use something called a unit multiplier. So for example, in 4A, it asks us to convert 15 meters to millimeters. So you might know what that is off the top of your head. You know that you can probably type that in somewhere and convert it, all that good stuff. But mathematically and in sciences, we want to make sure that we know how to do conversion factors. All right, so what do I mean by that? So that means that I'm going to start off with my first value, which is I have 15 meters. And I'm going to abbreviate meters as M, so you don't have to watch me write it out. And then what we're going to use is we're going to use a conversion factor to change this into millimeters, because we want to know how many millimeters are in 15 meters. So what do I mean by conversion factor? Well, I am going to use a factor that converts millimeters to meters. So I know from studying my facts a long time ago that in 1 meter, there is 1,000 millimeters. This is the metric system, so everything's on base 10. Okay, I know that's true. So I'm able to take this conversion that I know and use this as a unit multiplier. And I know I'm making it really wordy, but I just want to make sure that we all get it. So what I mean by that is I am going to say that for every 1 meter, there is 1,000 millimeters. So I took that conversion fact that I knew and I put it in this form called a unit multiplier. Okay, so a lot of times people say, why can you just randomly, this is kind of the special part of it. Why can you just randomly multiply by 1,000 millimeters over 1 meter? Like, why? You're not just allowed to do that in math. Like, I can't just say, I have the number 4 and I'm going to multiply it by the number 5 and make it 20. But the reason that you're allowed to do this is because if you look at 1,000 millimeters divided by 1 meter, those are the same units. They're just expressed in different, or they're the same values. They're just expressed in different units. So really, when you multiply by this, it's really like multiplying by the number 1. Okay, and we're allowed to do that. Remember, in our properties, we have the identity property. So if you have A times 1 equals A, you're allowed to multiply by 1 as much as you want. You can multiply, any number by 1 and you get the same number back out. So that's why you're allowed to all of a sudden out of the blue multiply by a unit multiplier, because this is really the number 1, right? 1,000 millimeters divided by 1 meter is 1. It's 1 unit because they mean the same exact thing. So, we know that 1 meter equals 1,000 millimeters. So this could be 1,000 millimeters divided by 1,000 millimeters, which is 1. Or it could be 1 meter divided by 1 meter, and that's 1. So that's why you're allowed to randomly multiply when you're doing conversions. I don't know if anyone's ever explained that before, but I think it's important to know why all of a sudden you can just multiply by this. And that's that word unit multiplier. A unit is like a unit of 1, and you're allowed to multiply by that. So I know the math part's easy in this, but I just kind of want to explain the background of why you're able to do it. And then what this creates is an opportunity for us to convert, and also lets us cross things off, which I think is super fun in math. So I always like to cross things off. The other thing that some people do to kind of make this a little easier for them to visualize is they just make this 15 over 1. So you have your fractions all lined up. So what I mean by crossing off is when I look at this problem, before I even look at the numbers, I'm going to look at my units. So I have a meter unit in the numerator over here, and I have a meter unit in the denominator over here. So I'm actually able to cross off the unit of meters because they cancel each other out. One is the numerator, one's in the denominator. And then my leftover conversion is in millimeters, which is what I want. I want an answer in millimeters. So then really all that's left for me to do is actually do the math. So I need to do 15 times 1,000. So 15,000. And then my units across the top, I'm just left with millimeters. Okay. And then across the bottom is 1 times 1 and no units. So technically, I could put a 1 under there, but I don't even need to, right? So I know that off the bat, millimeters and meters is a pretty easy conversion, but 15 meters is 15,000 millimeters. And I just wanted to explain this idea of unit multiplication. Have you guys heard that before, or? Okay, all right. I know it's kind of like you've probably seen it before, but hey, that's good. Sarah, you good? I'll let her type back to me. Ah, good question. She said, does the crossing out units thing only work for the metric system? No, it does not. As per example number B. No, letter B, 4B. Yes, hours and minutes is technically in the metric system, but you could use that for our standard system. So like if you have, let's do a super easy one. If you have, and you guys know the answer to this, 6 inches to feet, okay? So what you would do is you would say I have 6 inches, right? And then what would my unit multiplier be? Well, I know that 1 foot is 12 inches. Okay. Again, sorry for the crazy stuff. So I need to put my unit multiplier in so that I basically get rid of inches and convert it into feet. So the way I would do that is I would write that for every 12 inches, there's 1 foot. And the way that you know which way to write it is that you want to be able to cross off your inches and only have feet left over. So I wouldn't want to write 12 inches in the numerator and 1 foot in the denominator because I'm not going to be able to cross out inches then. I'm going to get square inches over feet, which I don't want to do. So then when you do this, you get to cross off inches and you're left with just feet, and you're going to come up with 1/2 of a foot, which you guys knew, but just kind of shows how the unit multiplier works. So we can use it for different things, like, for example, 5 hours to minutes. Again, you probably know how to do this, but that's okay. We're going to just do it kind of quickly. So we have 5 hours. Okay, so what do we know about hours to minutes in terms of unit multipliers? So for every 1 hour, how many minutes is that? 60, yep. So for 1 hour, there's 60 minutes. So then hours crosses out hours, and we're left over with minutes. And 5 times 60 across the top is 300 minutes. Again, maybe something you could have done in your head, but it just kind of drives that point home so that when you're in, physics class and you have to convert something, you'll be able to do it easily. Oops, sorry. The last one's a little bit more tricky. So, not crazy, but slightly more tricky. So we have 6 feet per second to miles per hour. Well, let me give myself a little more room here. I wish paint had a bigger eraser. I have a good way to erase here. We'll go like this. Okay, that was not very pretty, but you guys get the picture. Okay, let's go with red. 6 feet per second to miles per hour. So we have 6 feet per second. So this one's a little weird because we have unit multipliers. Second. We have units in the numerator and the denominator, right? And our end goal is to get to miles per hour. So we need to convert feet to miles and seconds to hours. So this is where kind of when you start to get in a little more complicated problem that it can actually help you out, because these two you could probably convert straight off, right? But we have to think about this a little bit. So what we're going to do is we're going to take it one step at a time. All right. So first we're going to look at feet to miles. So let's deal with that first. So did anybody memorize the fact how many feet are in a mile? If you didn't, it's okay. So in 1 mile, there are 5,280 feet. So that's one of those conversions that we know. Okay. So when we go to put in the conversion factor here, I want to put feet in the denominator because I want to be able to cross out my feet in the numerator here. So I want the miles to be at the top and the feet to be at the bottom. And that way, when I go to cross out, the feet will cross out the feet and I'm left over with miles. But I can't just do miles to feet. I have to actually put in the numbers. So I'm going to put 1 mile and I'm going to put 5,280 feet. Okay. So we've got feet taken care of. And I'm sorry for the messy writing, but we got feet taken care of and we're going to end up with miles. So that's good. So we can actually use more than one unit multiplier because we still have to deal with seconds to hours. Now, I can never quite remember how many seconds are in an hour, but I can remember there's 60 seconds in 1 minute. And I can remember that there's 60 minutes in 1 hour. So I can use these to basically double convert seconds to hours. Now, if you remember, it's 3,600. You can use that too. All right. So now I have seconds down here. So in order to cross off seconds, I have to put seconds to minutes in this order. Because what that's going to let me do is for 60 seconds, there's 1 minute. So that lets me cross off seconds to seconds. And I'm left over with minutes. Well, I'm getting closer. I'm trying to get hours down here, but I've got minutes. So I know that in 60 minutes, there is 1 hour. So if I cross off minutes to minutes, I'm left over with, exciting stuff, miles per hour when I just look at the units. But now I actually have to do the math, right? So in my numerator, I have 6 times 60 times 60. So I have 6 times 60 times 60. And in my denominator, I have 5,280. So if I convert that, if I do that math, 6 times 60 times 60 divided by 5,280, I end up with 4.1 miles per hour. All right. So that makes sense. It's a good thing to practice it. Okay, cool. Sarah, is that good? Yep, awesome. All right, so let me go ahead and do a few minutes of 1.2. So that way, if you want to get started on your homework in 1.2, you can do that. We probably won't finish all 1.2 though. We'll just go up because, Connor, do you leave at 11:40 or do you need to leave a little earlier? Okay. All right. We don't want you to be late to make ice cream. That would be like a tragedy. Yes. Okay, so let's do a couple of these really fast. The one thing that I wanted to review with everybody, which I probably will review again on Monday, is order of operations. So, you know what? Well, let's just go ahead and wait for Monday. Let's go ahead and wait for Monday. I'll give you 2 minutes of order operations. I'll probably do the same thing on Monday. And then if you want to go ahead and look at some of the ones in 1-2 that you can, but just since we don't have a lot of people here, we'll do that. So the one thing I just wanted to review with everybody is order of operations. And I don't know, depending on what textbook you used or what your parents used, you might have a different acronym for this, but a lot of times you'll see this as PEMDAS. Has anyone heard of PEMDAS before? Connor? Sarah? Okay, Sarah has, Connor's not. That's okay. So PEMDAS is simply an acronym to help you remember order of operations. So what that means, but by order of operations, that means how do we solve math problems, right? How do we do our algebra problems? So for example, I'm sure you guys know if you have three, I'm sure these float around the internet from time to time too. They'll have like, what's the answer to 2 times 3 plus 5? All right. So if you knew nothing about math, you would think, oh, well, I could do 2 times 3 is 6 plus 5, that's 11, right? That's one solution. Or I could do 3 plus 5 is 8 times 2, which is 16. Right? I could do these first. But that just feels wrong to add those two first, right? 3 plus 5 first and then multiply by 2. Mrs. Ross, don't do that. That's wrong. Or I hope it feels a little bit wrong. It does look like a little evil. Sarah said that my 11 looks like an evil smiley face. So what kind of rules the world of algebra is something called the order of operations. So that tells us that when we have a math problem, we need to do multiplication before we do addition, and that we need to do division before we do subtraction. And there's a few other things that we have to do before we even multiply. So PEMDAS is just an acronym to remember that. You could remember this a different way. Some people use like, please excuse my dear Aunt Sally. There's different variations of that. But it's kind of helps us remember that. So the P stands for, in PEMDAS, stands for parentheses. Okay, so whenever we have a math problem and we have something in parentheses, we have to do the parentheses first. Always, always, always. They get the priority over everything else. So we always do our parentheses first. And then the E stands for exponents. So if we have any exponents, we got to do those next. And then we get to the M and the D, which stand for multiplication and division. All right. And those multiplication and division can kind of be done together as a group. And then last up, our friends, addition and subtraction. So a lot of times people know these rules like just inherently, like you've done PEMDAS before. You know not to add 3 and 5 together before you multiply by 2. But PEMDAS is just kind of an easy way to do that. So that's the order of operations. And then that's going to kind of lead to, in 1-2, we're going to talk about exponents and simplifying expressions and just kind of review from Algebra 1, some of that stuff. So that's what's coming up on Monday. All right. So you'll see PEMDAS again Monday and you guys will be experts. Good deal. All right. Well, thank you guys for coming. I'm glad we connected. If you have any questions between now and Monday, let me know, but it should be a pretty easy, just kind of ramping up week. And next week, we'll kind of start full in and get going on some other concepts. All right. Have a great day, guys.